You explain the problem once. The first representative listens, checks a few details, and then says the issue needs another team. A second representative joins. Then comes the familiar request. Can you explain what happened? From the customer's side, this feels like one conversation with one company. Inside the service operation, it may already have become several different tasks, moving through different queues, permissions, tools, and areas of responsibility. The system behind that experience is skill-based support routing. Its purpose is not simply to move customers around. It is to classify a request and direct it toward a team or agent who is more likely to have the right expertise, access, or tools. That specialization can make a large support operation more manageable. It can also create handoff points where context must survive a change of owner. That is where the experience can begin to break apart. The first stage is classification. When a request enters a support system, it may be identified by issue type, product area, account status, communication channel, urgency, language, or another recorded attribute. Some of that classification may happen automatically. Some may depend on questions asked by the first representative. The request is no longer just a customer problem. It becomes a ticket with conditions attached to it. Those conditions help determine where the work can go next. A billing question may require one group. A technical problem may require another. An account security issue may require a representative with different access. A complex product fault may need a specialist who can see tools or records unavailable to a general support agent. The first representative may understand the problem and still be unable to complete the task. That distinction matters. Knowing what is wrong is not the same as having permission to change it. A representative may be able to inspect an account, but not issue a refund. Another may be able to adjust billing, but not investigate a technical failure. A specialist may have the necessary tool, but only handle requests placed into a particular queue. The system, therefore, separates diagnosis from ownership. Once the request has been classified, it enters a routing decision. The system checks which groups are eligible. It may consider required skills, agent availability, current workload, channel, queue rules, and access boundaries. The request may be placed into a standard queue, a custom queue, a primary group, or a fallback group, depending on how the service has been configured. From the outside, nothing about this structure is visible. The customer sees the same logo, the same account, and often the same chat window or support thread. Internally, the request may be leaving one ownership domain and entering another. That transfer creates a new question. What travels with the request? Some context can be recorded. The ticket may preserve the original message, account details, category labels, internal notes, status changes, previous replies, and a history of which groups handled it. In a well-connected workflow, this record gives the next representative a path back through the case. But recorded context and understood context are not the same thing. A ticket history may show that the customer contacted support, but not why one detail matters more than another. A note may summarize the issue, but leave out the sequence that made the problem unusual. A field may capture the product category while missing what the customer already tried. A long conversation may technically be available, yet still require the next representative to reconstruct the important parts. This is why a customer can be asked to explain the same issue again, even when a record exists. The information may be incomplete. It may not be visible to the next team. It may be stored in a form that does not match the next team's task. Or it may be present, but difficult to interpret quickly. The handoff itself does not automatically erase context, but it creates a point where context must be transferred, accessed, and understood. To see the mechanism clearly, imagine the support request as a map. At the far left is one customer problem. The first node is intake. The customer describes what happened. The second node is classification. The request receives labels, categories, or skill requirements. The third node is the first queue. A general support group may gather information and determine whether it can resolve the issue. Then the path reaches an access boundary. On one side is the current representative. On the other is a team with a different tool, permission, or area of expertise. The ticket crosses that boundary and enters a new queue. At the same time, two different context paths appear. One path is the recorded history: messages, notes, ticket fields, previous actions, and ownership changes. The other path is the spoken explanation, the details the customer may need to repeat so the next representative can understand the case. Ideally, the recorded path carries enough useful context that the spoken path remains short. If it does not, the customer may have to rebuild the story. The request then reaches a second ownership point. The new team may resolve it, return it, or send it onward if another permission or skill boundary appears. That is the support handoff loop. One visible conversation can become a sequence of internal classification, queue placement, eligibility checks, ownership changes, and context transfers. A current example can be found in the way Zendesk documents omni-channel and skills-based routing. In its English language cloud documentation available in July 2026, Zendesk describes support workflows in which tickets can be routed according to groups, queues, agent availability, capacity, priority, skills, channel, and configuration. Depending on the plan and setup, requests can enter standard or custom queues, move through primary or fallback groups, and, in supported situations, re-enter routing after reassignment. The same documentation also describes different agent roles and access scopes. One agent may be able to view or handle only certain tickets, groups, or organizations, while another may have broader permissions. That makes Zendesk useful as a bounded example of the mechanism. It shows how one incoming request can be classified, matched to skills, placed into a queue, assigned to an eligible group or agent, and then reassigned if the first destination is not the final owner. But this example has limits. Zendesk documents what the software can be configured to do. It does not establish how every organization configures its support operation. It does not show how often customers repeat information. It does not prove that a specific transfer was necessary, efficient, careless, or avoidable. The important point is the structure, not the brand. Skill-based routing exists because support work is not uniform. Research on service operations has long treated support centers as environments where different request types require different combinations of skills. Training every representative to handle every problem may be impractical, expensive, or impossible. Some tasks depend on specialized knowledge. Others require restricted access or tools that should not be available to every agent. Specialization can therefore improve handling efficiency. It can help direct a technical issue toward technical expertise. It can protect sensitive actions behind permission boundaries. It can prevent one general queue from becoming responsible for every possible problem. The trade-off is that specialization divides the service into ownership domains. Each domain may be efficient at its own part of the process, while the customer experiences the entire journey as one unresolved issue. That difference in perspective is the central blind spot. The customer sees one company. The support operation sees categories, queues, groups, skills, permissions, capacity, and ticket states. The customer thinks, "I already explained this." The next team may think, "This is the first time this queue has received the case." Both perceptions can be accurate at the same time. A repeated handoff can then create two forms of fragmentation. The first is information fragmentation. Relevant details may be spread across the original message, internal notes, ticket fields, previous replies, and the customer's memory. No single element necessarily contains the complete picture. The second is ownership fragmentation. Different teams may control different stages of the outcome. One team identifies the issue, another verifies account information, another has the tool needed to make the change. Each team may complete its own task while the overall problem remains unresolved. This can extend resolution time. Every ownership change creates another point where the request may wait for an eligible agent, enter a queue, be reclassified, or require additional interpretation. A transfer that is operationally correct can still add time from the customer's perspective. That does not mean transfer are inherently poor service. A transfer may be the responsible action when the current representative lacks permission, expertise, or access. Keeping the request with the wrong person could produce a slower or less accurate outcome. Routing quality depends on more than the number of handoffs. It depends on whether the request was classified correctly, whether the right team was available, whether the next agent could access the relevant records, whether the recorded context was useful, whether staffing matched demand, and how complex the case was. The same transfer structure can therefore produce very different experiences. In one case, the first representative gathers the right information, the ticket reaches the correct specialist, and the next agent continues without interruption. In another, the issue is classified too broadly, enters the wrong queue, loses important context, and requires the customer to rebuild the story. The existence of routing does not determine which outcome will occur. The mechanism only explains why the experience is possible. It also explains why the phrase, "one support conversation," can be misleading. A conversation is what the customer sees. A routing chain is what the service operates. The first is continuous because the customer's goal has not changed. The second is divided because the internal work may require different owners. That is why the same issue can feel repetitive even when every representative is completing a legitimate part of the process. The service may be organized around specialization. The customer is organized around resolution. Those are not always the same unit. The useful mental model is to separate the visible conversation from the internal ownership chain. When a support request is transferred, do not imagine one conversation simply moving to another person. Imagine one customer problem being converted into several internal tasks, each attached to a different queue, skill, permission, or tool. The customer experiences one company conversation while the service processes the issue through several specialized ownership domains. One customer conversation versus several internal queues and ownership domains.